Well guys, today we are going to discuss analysis of variance technique for unbalanced data. To understand this, let us take an example, right? So let's suppose the data is, so this is example and this is the data. Given the following data showing the daily sales of 4 garment stores, namely Vadut Home Store, Imperial, Day to Day and Chinwan at Peshawar. Perform a one-way analysis of variance to test whether the average sales of the 4 outlets equals or not. Use level of significance by 5%. So we can see the data. This shows the average sales in lakhs, right? And we see the data is not balanced because here one observation is missing. Three observations are missing here, and 2 observations are missing here, and 1 observation is missing over here. So the dash represents the missing values. So this data is unbalanced, and for this we can apply the analysis of variance technique. So the procedure under one-way analysis of variance technique for this type of data is outlined as, since we know that there are 4 populations, Vadut Home Store, Imperial, Day to Day and Chinwan. So we extend our analysis to the equality of 4 population means. The solution is something like, you define your null hypothesis H naught, says the data is given in columns, so the mean will be mu dot 1 is equal to mu dot 2 is equal to mu dot 4 is equal to mu dot 3, and this is equal to mu dot 4, which means that the average sales of the 4 outlets is equal. Your alternative hypothesis is H1. The average sales of the 4 outlets are not equal. So mu dot 1 is not equal to, mu dot 2 is not equal to, mu dot 3 is not equal to mu dot 4. This is the first step. The second step contains choose appropriate level of significance, but this is given, we have to take it by 5% because this is given in the question, because use level of significance by 5%. So that's why we are taking it by 5%. Test statistic to be used in this case, test statistic, this is equal to F. We will use F statistic, and clearly F statistic is given by SC square divided by SE square, and SC square, this is the variance of the columns and this is the variance of the error. Variance of the column is given by column sum of square divided by column degree of freedom, and error sum of square and divided by the degree of freedom of the error. The fourth step contains computation of test statistic. So computation of F. For computation we need certain sum of squares. For example, we need number first, total sum of square. Total sum of square, this is equal to double summation xij square minus t double dot square divided by n. N is the number of observations. In our case, n is equal to 12 because this is our 22. This is a 22 days sale. If we count these values, it is equal to 22. So that's why n is equal to 22 in this case. Then you need to calculate the column sum of square, and the column sum of square for unbalanced data is equal to summation t dot j square divided by ri, not r, divide minus t double dot square divided by n. T double dot square divided by n is known as correction factor. Okay. Then you need to calculate error sum of square. Error sum of square, and error sum of square is given by the difference between, if you subtract the column sum of square from the total sum of square, you get the error sum of square. You then need to develop an Anova table. Anova table. And normally Anova table contains 5 columns. The first column contains sources of variations between columns and within columns. The second step contains degree of freedom. Degree of freedom. The third step contains sum of square. Fourth step contains mean square error. And the last step, F calculated value. Sources of variation between columns and within columns. Within column is also known as error. And here you report the total. Now you have to do some necessary computations. For example, you need to calculate total sum of square, column sum of square, and then error sum of square. For this you have to calculate certain things. You have to complete the table by doing some necessary computations. And what are the necessary computations? The necessary computation contains, you have to complete this table by doing some necessary computations. For example, this value is missing, this value is missing, this one, similarly this, and this. These values are missing. First of all, we need to add these values up, and it will be t dot j. If you add all these values, it is equal to 24. These values are 24. Alright, if you add all these values are equal to, the sum of these values is 35. The sum of this column, this is equal to 42, and the sum of this column, this is equal to 18. And if you add up all these values, the sum of all these values, this is equal to 119, and we can name it as t double dot. Then we have to square these values. We have to square all these values. Now the question is, how can we square it? T dot j square. And the square of 24, this is equal to 576. The square of 35, this is equal to 1225. The square of 42 is 1764, and the square of 18, this is equal to 324. And if you add these values up horizontally, this is equal to 3889, and this is nothing else, this is summation t dot j square. And ultimately we have to take the square of all these values. For example, the square of 2 is equal to 4, The square of 5 is equal to 25. The square of 6 is equal to 36. Similarly, 16, 9 and 16. The square of 5 is equal to 25. Similarly, 64, 49, 81 and 36. Now the square of 7 is 49 and similarly 25 and 36, 64, 49, 25 and 16. Finally, the square of 3 is 9 and 36, similarly 25 and 16. Now you have to add these square values, and if we add these square values, the sum of all these square values, this is equal to 106. Similarly, the square of all these values, this is equal to 255. The square of all these values, this is equal to 264, and the sum of all these values, this is equal to 86, and the name of this row is summation xij square. X is all these values. I row, these values contain I rows and j columns. Okay, so this is, and this summation stands for the sum of all these values. Okay, and if you again sum these values horizontally, the sum of all these values is equal to 711, and you have to put an other sign for this, another summation for this sum. It will be double summation xij square. This one summation stands for the totaling of these data column wise, and the second summation represents you have add up the total once again horizontally. So that's why this value is double summation xij square. Square represents the square of all these values. Since you have added the square of all these values, this whole data, this is x, which contains I columns, I rows and j columns, and this double summation means you have summed the square of all these values up vertically and then horizontally. So that's why this is double summation xij square. So remember these values, right? T double dot is equal to 119, summation t dot j square is equal to 3889, and summation xij square is equal to 711. Since we know that double summation xij square, this is equal to 711 minus t double dot square. T double dot is equal to 119 square and n is equal to 22. Okay, and similarly summation t dot j square, this is equal to 3889, but you don't need to add these values up. You don't need this sum over here. The reason is you have different rows for different t dot j square. So how can we calculate this thing? We can calculate this thing as, you have to take this value and it should be divided by the number of rows in first column, 1, 2, 3, 4, 5 and 6. Similarly, you have to add this with this value 1225, and it should be divided by the number of rows equal to 1, 2, 3, 4, 5 this time, plus you have to choose this third value, and it should be divided by the number of rows in the third column, which is equal to 7 in this case, because this is 1, 2, 3, 4, 5, 6 and 7. And similarly, you should take this value ultimately, and it should be divided by the number of rows in the last column. The number of rows in the last column is equal to 4. So how can we do that? Look at this. So since we know that the first value is 576, and it should be divided, the number of rows is equal to 6, plus the second value is 1225, and the number of rows in this case, this is equal to 5, plus the third value is 1764, and the number of rows in this case is equal to 7, or plus the last value is the last value of summation t dot j square. T dot j square is 324, and it should be divided by the number of rows in the last column, which is equal to 4, or minus t double dot square, I mean 119 square, divided by n is equal to 22. Okay, so if you calculate this, you get the total sum of square is equal to 67.3. Similarly, if you calculate the column sum of square, the column sum of square is equal to 30.32. However, you need the error sum of square. Error sum of square can be obtained by the difference between the total sum of square and the column sum of square. So this is equal to 67.3 minus 30.32, and the error sum of square is equal to 37 almost. Now you have to put these values in the Anova table. Remember, in this case, the degree of freedom between column degree of freedom is equal to c minus 1, but we know that there are 4 columns, so 4 minus 1, this is equal to 3. Similarly, error, the degree of freedom for error, which is equal to n minus c. N is equal to 22, number of column is equal to 4, so this is equal to 18. And total degree of freedom, this is equal to n minus 1, and this is also equal to the sum of these two, which is equal to 21. Even if you add these two values, 13 plus 18, this is equal to 21. An alternative way to obtain this, you have to subtract 1 from the total number. Total number of values in the question is equal to 22. So if you subtract 1 from the 22, you get 21. Next, we need to calculate between column sum of square. Column sum of square. So column sum of square we have already calculated it. This is equal to CSS, represent the column sum of square, and this value is equal to 30.32. Then you need to calculate the error sum of square, and the error sum of square, it has also been calculated over here. This is equal to 37, and if you add these two values, you get the total sum of square, which is equal to 67.3. And what is this? This is the total sum of square. This is TSS. Okay. Ultimately, you need to calculate SC square. SC square. SC square is obtained by dividing the column sum of square by its own degree of freedom, which is equal to c minus 1. CSS, this is equal to 30.32, and its degree of freedom is equal to 3. So this is equal to SC square. Similarly, if you want to calculate SE square, this is equal to error sum of square should be divided by its own degree of freedom, n minus c, and error sum of square, this is equal to 37 divided by 18. So you get the error SE square, and these two values are These are the values. Okay. Now you need if calculated value. If calculated value is equal to SC square divided by SE square. SC square, this is equal to 10.1 and SE square is equal to 2.05. So if calculated value is equal to 4.92, this is F calculated value. So we are done with the fourth step. What was the fourth step? Computation of F. So we have computed this value. This is equal to 4.92. Now you should go for the fifth step, which is equal to critical region. So critical region is critical region at F alpha C minus 1 and n minus c degree of freedom. F alpha c minus 1 is equal to 3 and n minus c, this is equal to 18 degree of freedom. Alpha is equal to 5% at 3 and 18 degree of freedom. So you have to use the F table for 5% level of significance, which is given by this. So look at this. This 5% level of significance. This is a table of 5% level of significance. Now, how do you see the value in this table? This is nu1. Nu1 represent c minus 1 and this is nu2. Nu2 represent n minus c. Since c minus 1 is equal to 3, so you have to choose 3 from the row. And n minus c is equal to 18. 18 should be taken from the column. Okay. So this is 3 and this is 18 and the respective value is equal to 3.16. So this is the table value 3.16. So this table value is 3.16. Alright. If you sketch the graph of F distribution, it will be something like this. This is the critical region, 0 plus side, and this is the critical region, and the table value is 3.16. Look at the computed value, whether it is greater than table value or it is less than. So clearly 4.92 is greater than table value. 4.92 falls in rejection region because this is the region of alpha and this is the region of 1 minus alpha. This alpha region shows rejection region and 1 minus alpha region shows acceptance region. Since our F calculated value falls in the rejection region, therefore our decision is reject H naught, and we conclude that no, the average sales of the 4 outlets is not equal. So we reject H naught. So this is how to carry out one-way analysis of variance for unbalanced data. By unbalanced data we mean when there are missing values in the data set. The Anova procedure for one-way analysis is just similar to that of balanced data except one step, that is the column sum of square. For balanced data, you take the column, the aggregate of all these values over here. You utilize this value, but in this case we didn't utilize this value. This is so because the number of rows varies across columns. That's why we have divided this square value by number of rows in the first column. We divided this value by the number of rows in the second column, and so on. So we didn't utilize this value. This value is utilized only when the data is balanced. Thank you. Thanks for watching.